Welcome, first-year design students. So glad to have you here for this explainer on how to bring your brilliant ideas to life, all while saving crucial time and resources through the art of prototyping. Look, if you're just starting out in the world of interactive systems, I know it can feel incredibly overwhelming. You might be sitting there wondering, how exactly does an abstract thought in my head transform into a fully functional, real-world digital product? Well, today, we are going to demystify that exact process. We're going to explore how to safely nurture an idea from a rough, messy sketch on a napkin to a highly polished system. Let's get into it. Our roadmap for today covers 5 key stops. We'll start with a welcome to design thinking, move into defining the prototype, explore the iteration cycle, trace the journey from sketch to hi-fi, and finally, break down exactly why prototyping saves money.
All right, kicking things off with Section 1, Welcome to Design Thinking. Now, our main goals here are focused on building a rock-solid foundation for you. We aren't just jumping straight into the black and white science of things or specific coding applications. Instead, we're really looking at the underlying structure and theory of interaction design. We're putting a massive emphasis on core methods like sketching and storytelling right out of the gate because, honestly, prototyping is ultimately about clear visual narrative. It's not just about technical ability. You'll also get a feel for the terminology and the everyday tools of the trade. Seriously, if you can sketch an idea and tell a compelling story about it, you are already designing.
Moving right along to Section 2, Defining the Prototype.
So according to the standard dictionary definition, a prototype is simply a first, typical, or preliminary model of something from which other forms are developed or copied. But I really want you to focus on 2 specific words there, first and preliminary. You see, a prototype is absolutely not the finished, polished product that gets shipped to the consumer. Rather, it's the raw, preliminary model that allows you to test out your assumptions early and, importantly, test them often.
Basically, think of it as your archetypal example. It's the launching pad for your future designs. Whether that's a quick sketch on grid paper, a physical model made out of cardboard, or an early wireframe on a screen, it is simply the original template. It's the mold. It's the very first tangible representation of what you're trying to achieve, and it gives you a safe space to experiment before committing entirely to a final direction.
Which brings us to Section 3, the iteration cycle.
So how do we systematically create and refine these models? We use the iteration cycle. This means stepping logically from understanding the user to prototyping a solution and finally testing it out in the real world. These are the classic 5 stages of design thinking. We start by empathizing with our users to uncover their real emotions and stories. Then, we define the core problem by creating a human-centric statement. Next, we ideate, meaning we brainstorm radical ideas with zero judgment. Then we actually build a prototype, creating low-resolution objects so we can learn quickly. And finally, we test those prototypes to gather data and, frankly, to embrace potential failure in a completely safe way.
Now, while the standard D-School process lays out these steps neatly from empathize to test, you've got to notice the fine print here. This process is not necessarily linear. You apply these stages as needed. Sometimes testing a prototype forces you to go all the way back to redefining the initial problem. It's an incredibly fluid, dynamic process.
Honestly, whether you visualize this process stretching out as a linear timeline with arrows looping backward or mapped onto a continuous, never-ending circle, it really doesn't matter. The rhythm of understanding, exploring, and materializing remains exactly the same. The absolute core takeaway here for U.S. first-year students is that a design is never truly finished. It just constantly loops back on itself as you learn more and more about your user.
At its most basic, foundational level, iteration is just a continuous infinity loop. Observe the real world, reflect on your insights, and make concrete forms. If you forget all the complex terminology we cover, just remember this infinity symbol. Observe your users, reflect on what they need, make something to solve their problem. Then, take what you made, observe how they use it, and start the whole loop over again. That right there is the true heartbeat of prototyping. Okay, let's jump into Section 4, from sketch to hi-fi. To build our prototype from a fragile idea to a robust system, we climb what we call a ladder of fidelity. We start with simple lo-fi wireframe sketches, flesh out mid-fi mockups, and finally engineer hi-fi interactions. Fidelity just means how close the prototype looks and feels to the actual final product. Lo-fi, or low-fidelity wireframing, is quick, it's cheap, and it's almost always done with just a pen and paper. As we test and gain confidence, we invest a bit more time into mid-fi mockups to figure out layout and structure. And then, only at the very end do we build hi-fi interactions that actually look and behave like the final software.
By stepping through these collections of sketches and mockups, your design achieves revolutionary improvements through safe, steady evolution. This is a massive concept to grasp. You don't just sit down on day one and magically invent a revolutionary, perfect system. No way. You achieve revolution via evolution. You iterate, you sketch, you test, you refine. Over time, all those tiny evolutionary changes compound into a truly revolutionary final product.
And that brings us perfectly to our final part. Section 5. Why prototyping saves money.
Now, you might be asking yourself, why not just skip all the messy sketches and build the final product immediately? Well, identifying and resolving design problems early through prototyping is essentially a real-world superpower that prevents disastrous production failures. If you attempt a revolution, meaning you skip the evolutionary prototyping process and go straight to production, you're basically gambling. If you build a whole system and then realize the user hates it or it doesn't even solve their problem, you've just wasted countless hours and resources. Prototyping is literally your insurance policy.
So the crucial point here is this staggering mathematical reality. Fixing a mistake costs $1 in design, $10 in development, and a massive $100 if you wait until production. This is the golden rule of interactive systems. If you catch a usability flaw while you're just sketching out wireframes in the design phase, it costs practically nothing to fix. Just grab an eraser or a new piece of paper, represented here as $1. But if you don't catch it until the development phase, your developers have to rewrite the actual code, which costs $10. And if you ship it to production and then have to fix it, you're looking at recalling products, issuing massive software patches, and dealing with angry users. That is your $100 mistake.
Just look at that exponential spike. It beautifully illustrates exactly why rapid iteration and lo-fi sketching are absolutely the best ways to protect your budget and ensure your project actually succeeds. As a beginner designer, your greatest value to a team isn't just making things look pretty, it's identifying and resolving critical problems in that tiny dollar phase. By observing, reflecting, and making quick, cheap prototypes, you are actively saving your future teams thousands of dollars and saving everyone countless hours of frustration.
So, now that you see how incredibly powerful and cost-effective this methodology is, we've got to ask the ultimate question. You understand the definition, you know the continuous infinity loop of observation and creation, and you've seen the brutal math of catching errors too late. Every great digital experience you have ever loved started as a messy, low-fidelity sketch that someone was brave enough to test. So, are you ready to pick up a pen and sketch your first $100 idea? But remember, as your sketches evolve into complex systems, how will you know if you're asking your users the right questions during those tests? Well, we'll leave that for you to explore next time.